Okay, let's talk about section 13.5, the binomial theorem. First, we have to study some notation. Uh, Here, this is the first one called the factorial. N factorial. For any integer, positive integer, natural number, not positive integer, natural number, not integer. For all the natural number 1, 2, 3, 4, 5, n factorial is defined to be the product 1 times 2 times 3 times 4 and 2 times n. Okay, so this is a n factorial, the product of the first n natural numbers. Okay, so for example, if we have 1 factorial, it is equal to 1. Okay, if you have a 2 factorial, you just follow the computation. It's 1 times 2 is equal to 2. 3 factorial, 1 times 2 times 3 is 6. So on 4 factorial, 1 times 2 times 3 times 4, 2 times 3 is 6, 6 times 4 is 24. Okay, so there's no quick way to compute. You just do the computation. For example, if you want to get 7 factorial, let's skip some. So it is 1 times 2 times 3 times 4 times 5 times 6 times 7. Or just do the computation. 2 times 3 is 6, 6 times 4, 24. And 24 times 2 times 5, 120. 120 times 6, 720. 720 times 7 is 5,040. See, 700 times 7. 49, 49 plus 1, 50. So 7 factorial is going to be 5,040. Of course, you can imagine that if you have 100 factorial, it will take time, right? And this number grows very fast. It becomes bigger very quickly. Okay, so 7 factorial is 5,040. And actually, you see here in this computation, you actually find what? 5 factorial. If you stop here, you will get 5 factorial. If you stop here, you will get 6 factorial. All right. So actually, you want to get 7 factorial, you have to know all the previous factorials, and then you can get 7 factorial. So this is a factorial. This is a factorial. And factorial only defined for natural numbers. For natural number n. So far, we only define for n equal to 1, 2, 3, 4, 5, and so on. And sometimes we need this notation, 0 factorial. 0 factorial, by definition, is equal to 1. 0 factorial is a special definition. It does not follow the general way. The general way only works for natural numbers. And if you get a 0 factorial is defined to be 1. Okay, 0 factorial is defined to be 1. Okay, so this is the factorial. Okay, so what is a binomial theorem? Binomial theorem is about the expansion of x plus a to nth power. X plus a, the sum to nth power. We want to see if we expand it, what it is. For example, if you have n equal to 2, we know it is equal to x squared 2xa and a squared. If, well, just do the computation, plain computation, you will see it. If if you have n is equal to 3, you do the computation term by term. It's not that long. You will get is x cubed plus 3x squared a plus 3xa squared plus a cubed. Okay, it will take like 1 minute at most to compute it. And if you want to compute x plus a to 4th power, it will possibly take more than 1 minute. You will get x to 4th power plus 4x cubed a plus 6x squared a squared plus 4x a cubed plus a to 4th power plus a to 4th power. Okay, so it will take time, but it's not that serious, difficult. Well, they are just some simple smaller numbers. If you have n equal to 100, then possibly it will take long time, like 20 or 30 minutes to really do the expansion. And you also need to be very careful. You have no idea if you get it wrong or right, because so far we literally don't know what the expansion is. Okay, but just based on the current stuff, let's see what the pattern behind the expansion. Let's observe from here. You see, here you have x squared, x, and no x. And here you have x cubed, x squared, x, and no x. And here you have x 4th power, x cubed, x squared, x, and no x. No x, actually, you can consider it is x to 0th power. X to 0th power is equal to 1. So you just multiply a squared by 1, so you do not change it. Okay? So from here, what we can say that if we really expand this x plus a to nth power, what we are expecting? We're expecting, you see, here 3, here 3. We are going to have x to nth power, and next you will have 2, 1, 0, 3, 2, 1, 0, 4, 3, 2, 1, 0. So the power of x is decreasing 1 by 1 until you get x and x to 0th power. X to 0th power is equal to 1, so which means there's no x. So this is a x part. Okay? Now let's check the a part. A part here, no a squared. No a squared, a cubed. No a squared, a cubed, a to 4th power. Okay? So you see here the power of x is decreasing, and the power of a is increasing. And also, you see, here is x to 0th power, a squared. 0 plus 2 is 2. X to 1st power, a to 1st power is 1 plus 1 is 2. Here's x squared. You can also multiply it by a to 0. So you have 2 plus 0 is 2. So the sum of those two powers is always this power 2. Here's the 3. You can imagine. You can check. Here 3. Here 2 plus 1, 3. 1 plus 2, 3. 3 plus 0, 3. Okay? So here, this part, there's no a. So you will imagine it is a to 0. The first term, you need multiplied by a. Here you would need a squared. And here's a to power n minus 1. Here's a to power n. Okay? So this is the first term, second term, third term, and all the terms. So what we know? We know we must have those terms. So xn minus 1a, xn minus 2a squared, x times a to n minus 1, a to n. Those are the theoretical terms. Okay, you must have them. No missing terms. Okay, so that's something we can predict. But what are the coefficients? What are the coefficients? No, not this one. You see here, here you have two. The leading term has coefficient of 1. The final term has coefficient of 1. So this is 1. Okay, it's for sure a to n. It's always a squared, a cubed, a to fourth power. It's always 1. The final term is always 1. The first leading term always has coefficient of 1. So there's no additional coefficient. The question is, how do we get those 2, 3, 3, 4, 6, 4 stuff? Of course, when you have smaller powers, you can just do the computation by hand, you get it. But if you have a large number, for example, n is 100, n is 1,000,000, how do we predict the coefficients? So the binomial theorem is the theory with the help of factorial to give us the coefficients. Okay, the binomial theorem is to give us all the coefficients with the help of the factorial computation. All right, so now let's see how we use those factorial to get the coefficients. The first part is called evaluate n choose j. Let's ignore why we call it n choose j. We just say first we define if j and n are natural numbers or integers. We include the zeros, so we integers. With, see, 0 less than or equal to j less than or equal to n. So here this n has to be non-negative, j has to be also non-negative, and the j is not bigger than n. Okay, so for this pair we define n choose j to be n factorial over j factorial n minus j factorial. It's a ratio of 3 factorials. This is a n choose j. All these you can say n taken j at a time, but n choose j is better, shorter. N choose j. Okay, so this is the definition. First, we define this n choose j. Let's see some computation. For example, let's try to evaluate 3 choose 1. 3 choose 1 by definition what it is. So 3 is on top, so it's a 3 factorial. 1 j is, and 3 minus 1, so it's 2 factorial. This is product. In this formula, it's either quotient or product. There's no other addition or subtraction. Okay, now let's see. 3 factorial, we did it. It's a 1 times 2 times 3. 1 factorial is 1. 2 factorial is 1 times 2. In the evaluation of those n choose k symbol, it's better for you to cancel terms, not do multiplication and do cancellation. First, do cancellation. It will simplify the computation. For example, 1 you ignore it. 1 times 2, 1 times 2, they appear on top and on bottom, so you cancel them. So you only have 3 survived. So the 3 choose 1 is equal to 3. Okay, 3 choose 1 is equal to 3. The other one. So 4 choose 2. So 4 factorial. The top number always factorial, and the bottom number 2 factorial, and times 4 minus 2. The difference of them. 4 minus 2 is 2, so it's another 2 factorial. Okay, so 1, 2, 3, 4. 2 factorial 1 times 2, 2 factorial 1 times 2. Okay, so cancellation, 1 times 2, 1 times 2 cancelled. And then you can continue the cancellation. 1, you don't ignore it in the denominator. So 2 times 3 is 6. So 4 choose 2 is equal to 6. In the evaluation of this of this n choose j symbol, it's better for you to do cancellation first. It's very important. Okay, so you see 8 choose 7, so 8 factorial over 7 factorial. 8 minus 7 is 1 factorial. 8 factorial, 1, 2, 3, 4, 5, 6, 7, 8. 7 factorial, 1, 2, 3, 4, 5, 6, 7. 1 factorial is 1. See, it's very complex, but actually you can cancel most of the term. You only have 8 over 1, which is 8. Right? So it's not that serious. And of course, all those numbers are not big. In the textbook, they gave us this example, which has a label, label calculator. It means you really need the calculator to compute it. So by definition, it's a 64 factorial over 15 factorial, and 65. 65 minus 15 is 50 factorial. Okay, 65 minus 15 is 50 factorial. So let's see. So it's a 1 times 2 times 15, 51, 65. Okay, here 15, 1 times 2, 15. 50 factorial, 1 times 2, 50. Okay, all these things from top and bottom are product. Okay, so 1 times 2 up to 50 is cancelled with this 50. Okay, so what you have is actually in the numerator, it's a 51 times 52 times 65. And denominator is 1 times 2 times 15. There are 15 numbers. Sure, you can do the cancellation, but still it's a big number. In the exam, you will not see such huge number. Okay, in the exam, you will not see such huge number. You see here, even by the calculator, we are not going to really compute it. In the calculator, it's approximately 2.07 times 10 to power 14. There are 14 zeros. There are 14 zeros. It's a huge number. Okay, the factorial, when this difference is big, it's actually a large number. Okay, so that's not factorial. N choose j. This n choose j can be very, very big. N choose j can be very, very big. Okay. Okay, so we are going to use those n choose j to represent the binomial theorem. So let's see some more properties about this n choose j. So first, useful formula. Useful formulas. Number 1, n choose 0 is always equal to 1, and n choose 1 is always equal to n. N choose n minus 1 is always equal to n, and n choose n is always equal to 1. Is always equal to 1. Okay, so let's see. We just quickly compute. N choose 0 What is n choose 0? It's n factorial, 0 factorial, and n minus 0. N minus 0 is still n factorial. So n factorial cancel. 0 factorial, remember, we defined it to be 1. So it's equal to 1. The numerator is 1, denominator is 1, so the ratio is 1. Right? And second, n choose 1. N choose 1 is n factorial over 1 factorial and n minus 1 factorial. 1 factorial is 1, so you don't worry about that. The thing is n factorial over n minus 1 factorial. Okay? N factorial over n minus 1 factorial. What is n factorial? The product of the first n natural numbers. What is n minus 1 factorial? The product of first n minus 1 natural numbers. All of them are product. Of course, you can cancel up to n minus 1. You only have n here. Right? You only have n here. So this gave us an idea. N factorial, it is equal to n minus 1 factorial n times n. You have first n minus 1, the product of the first n minus 1 numbers, and you multiply additional one to form n factorial. Right? It's like 3 factorial is 2 factorial times 3, because 2 factorial is 1 times 2, and then times 3. That's exactly 3 factorial. Right? And the 10 factorial is 9 factorial times 10. Just keep multiplying the next integer. Right? And next, n choose n minus 1. N choose n minus 1, n factorial, n minus 1 factorial, n minus 1 is 1 factorial. And this, you see, these two numbers are equal. So it's equal to n. N choose n, you have n factorial, n minus n is 0. You have 0 factorial. And this one is identical to the first one. It's equal to 1. So those are the 4 steps. And those 4 steps actually corresponds to this. N choose 0 is the first part, all 1. N choose n is the final part, all 1. N choose 1, you see, this is a 2, 3, 4, and next you can expect 5. Why? Because 2 comes from this 2, 3 comes from the 3, 4 comes from the 4. So this is a n. And this one is the other trail, the other stuff. 2, 3, 4. So you can consider this 2 as a second one, or you can consider this 2 as a last second one, second last one, or last second one, whatever way. Okay? And 3 is a second last one. This 3 is a second one. This 4 is a second last one. This is a second one. Right? So that's all. The correspondence. Okay, and because later we're going to use them to represent the binomial theorem, and this n choose j is called binomial coefficient. N choose j is called binomial coefficients. Okay? Okay, now anyway, that's something we will see later. And now we want to see how do we organize them. There's so many. You see, from the definition, j is from 0 to n. J is an integer. So you will have, for example, for n is equal to 1, you will have 1 choose 1. For n is equal to 2, you will have, 1 choose 0 and 1 choose 1. 1 choose 0 and 1 choose 1. There are 2. N is equal to 2, you will have 2 choose 0, 2 choose 1, 2 choose 2. n is equal to 3, you will have 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. N is equal to 4, you will have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. So when n is the 4, you have 5 terms. N is a 5, you have 6 terms. N is 6, you have 7 terms. So you always have additional term. When n is 0, of course, you just get 0, because x plus a to 0's power is equal to 1. Okay, so if you evaluate them, let's see what we have. 1 choose 0. Anything choose 0 is 1, so we have a 1. 1 choose 1. N choose n is a 1. So this is the first two. 2 choose 0. 2 choose 0 is a 1. 2 choose 1. Choose 1 is 1. Sorry. 2 choose 1. What is 2 choose 1? 2 choose 1 is n. N choose 1 is n, so this is number 2. 2 choose 2. N choose n is 1. And 3 choose 0. 3 choose 0 is 1. Whatever number choose 0 is always 1, so this is always 1. 2, 3, 4. Okay, 4 is 1. And this part, choose 1 part, is going to be 2, 3, 4. 2, 3, 4. And choose, you see, missing 1, n minus 1. So 2, 1 is 2. 3, 2 is 3. 4, 3 is 4. And this part, follow this one, is always 1, 1. So only this one, only this number does not come from the those 4 observations, but we check that. 4 choose 2, we did the computation. 4 choose 2 is equal to 6. And if you want, we can figure out 5. The level 5, n choose, n is equal to 5. So it's a 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Okay, so it's 1, 1, 5, and 5. So we need 5, 2, 5, 3, and 5, 5, 2, and 5, 3. Okay, now let's compute 5, 2. 5, 2 is a 5 factorial, 2 factorial, 3 factorial. 5 factorial is 1, 2, 3, 4, 5. 2 factorial is 2. 3 factorial, 1, 2, 3. So 1, 2, 3 cancel with 1, 2, 3. The numerator 4 times 5, 20 over 2 is 10. And 5, 3 is 5 factorial over 3 factorial. 5 minus 3 is 2 factorial. Okay, that's exactly the same thing. Okay, so we actually organize those numbers, those n choose j, carefully. Then we have a triangle. So this is infinite triangle. If we put 0, 0 choose 0, is 1, so you will have a 1 here. This is an infinite triangle. Go to infinite. This infinite triangle is called the Pascal triangle. This is called Pascal triangle. And of course, how do we know the next level? How do we know the next level? We have the following observation. You see here, this number 2, it is the sum of the 2 adjacent terms from the previous level. So 2 is 1 plus 1. This 3 from the previous level, it is sum of 1 plus 2. And this 3 is the sum of 2 plus 1. This 4 is 1 plus 3. This 6 is 3 plus 3 is exactly 6. And 3 plus 1 is 4. See, that's our observation. And 5, 1 plus 4 is 5. And 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And the two sides are always 1. Two sides are always 1. This is a level, fifth level. Let's talk about the 6th level, for example. Follow the pattern. So the left side is 1. Right side is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. This is supposed to be the next level. Okay? So what is the next level? Let's check. The next level will be 6, 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Well, let's check if our observation is correct or not. We can just pick up, for example, we pick up this one. 6, 2, 3. 6, 2, 3 by definition is 6 factorial, 3 factorial. 6 minus 3 is 3 factorial. 6 factorial, 3 factorial. Okay, so you cancel 1 time, 1, 2, 3, 1, 2, 3. So the denominator is 2 times 3 is 6. Exactly cancelled. 4 times 2 is 20. So that's exactly 20. You can check others. For example, 6 choose 2 is 15. 6 choose 4 is also 15. So this is the observation. Whenever you have a complete level, you can predict the next level. Okay, you can predict the next level. It's always correct. It's faster than this evaluation. It's faster than this evaluation. Okay, so this is n choose j, n choose j. And we can find the n choose j one by one. The second part, use the binomial theorem. So what is the binomial theorem? In this section, let's state the theorem. The theorem says let x and a be real numbers for any positive integer n, any positive integer n. We have x plus a to nth power. Remember that we have the pattern. The first one is x to n. X to n, actually it has the coefficient n choose 0. And second one, we have x to power n minus 1 times a. Here is n choose 1. Then you can expect this. The coefficient of the third term is n choose 2x to power n minus 2a squared. In the middle, if you have x to the power n minus j and a to j's power, then the corresponding coefficient will be n choose j. N is always n. J is a coefficient, as j is a power of a. J is a power of a. Here there's no a, so you choose 0. Here there's only one a, you choose 1. The final one is n choose n because the power of a is n, so n choose n. So this is the binomial theorem. We know the coefficient for sure. We know the coefficient for sure. And this is a reason this n choose j called binomial coefficient. If you know the sigma notation, the sigma notation is like this. N choose j, x n minus j, a to j's power. J is from 1 to n. Okay, so we can expand it without hesitation. Okay. And those coefficients, so they are corresponding to the corresponding level. They're corresponding to the corresponding level. Okay, so let's see how do we use this to do some exercise. Use the binomial theorem to expand x plus 2 to 5th power. What is x plus 2 to 5th power? So here, a is equal to 2. A is equal to 2. So 5th power, so you see here the coefficients 1, 5, 10, 10, 5, 1. The corresponding part will be 1, 5, 10, 10, 5, 1. So the first one is always, coefficient is always 1. The second, the last one, the coefficient is always 1. So you have x to 5th power, and next you will have x to 4th power and times 2. And this will be 5, 1, 5, 10. Okay, let's first put the term and then put the coefficient. And then you have x cubed, 2 squared, x squared, 2 cubed, x 2 to 4th power, and 2 to 5th power. Okay, so that's the term x to certain power times a to certain power. And here is a 1, 5, and then this coefficient 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. Those numbers are from the Pascal's triangle. Those numbers are from the Pascal's triangle. The corresponding level of the Pascal's triangle will give us the coefficient of a binomial expansion. Okay, so first you write down this x to power n minus j, a to power j. The power of x is decreasing, the power of a is increasing. X decreases from 5 to 0. The power of a increases from 0 to 5. And then you're going to simplify it. See here, this is x to 5th power. 5 times 2 is 10. 2 squared is 4 times 10 is 40. 2 cubed is 8. 8 times 10 is 80. 2 to 6, be careful, this is x, not times. 2 to 6, 16. 16 times 5 is 80. 2 to 5 is 32. 2 to 5, 32. So this is the expansion. You don't have to really do the term-by-term computation, but you can still get the binomial expansion. Right? The next one, let's expand 2y minus 3 to 4th power using the binomial theorem. Binomial theorem. Okay. The binomial theorem only works for the addition. Here is subtraction. Subtraction, you consider it as addition with negative 3. Okay. Binomial theorem in our book only handles addition. Let's see how do we do it. This is x, this is a. So we have x 4th power. X cubed, negative 3 power 1. X squared, negative 3 squared. X negative 3 cubed. No x, just negative 3 to 4th power. This is a basic term. And then you're going to put the corresponding coefficient. The power is 4. Check here. You have what? You have 1, 4, 6, 4, 1. 1 is here, 4 is here, 6 is here, and 4 is here, and 1 is the final. 1, 4, 6, 4, 1. They are the coefficients. 2y is considered as x. It's not involved in the coefficients. Okay, now let's simplify it. 2y to fourth power is 2 to fourth power, y to fourth power. 2 to fourth power is 16. Okay, so 2y cubed is 2 cubed and y cubed, and times negative 3, so it's negative, negative 96y cubed. And negative 3 squared is positive 9. And you do this computation, it's 216y squared. And this part, negative 3 cubed is negative 27. It's negative 27 times 4 times 8 is minus 260y. Okay, and the final one is negative 3 to fourth power. It's positive 81. So if you have a subtraction inside the binomial theorem, you will always have alternating sum. It's plus minus, plus minus, plus minus, plus. Okay? The sign is alternating. It does not come from the binomial theorem. It comes from this negative 3. It comes from the negative 3. Okay? So binomial theorem only works for addition. If you have subtraction, add a negative number. And next, sometimes we don't need the whole expansion. Possibly we only need one term from this expansion. So find the coefficient of y to 8th power in the expansion of 2y plus 3 to 10th power. Okay? Well, how do we get a y to 8th, the coefficient of y to 8th power? We don't know, but let's just try to expand it. We will see the pattern. So first you have a 2y to 10, and then 2y to 9 times 3, with the coefficient missing, so let's just leave it here. And 2y to 8, 3 squared, 2y to 7, 3 cubed, and and then you get 2y and 3 to 9 plus 3 to 10. Just basic terms. So you have 10, 9, 8, 7, 6, up to 1 and 0. And 3 you have 1, 2, 3. Go. And then you will have here, this is a 10. 10 choose 0. This is 10 choose 1. 10 choose 2, because we don't write down the 10th level in the Pascal's triangle, so we have no idea what this is, but symbolically it looks like this. So n choose 3 because it's a 3 cubed, then n choose 4, here's n choose 9, and not n, 10 choose 9 and 10 choose 10. 10 choose 10 is 1, so the first and last are always 1. Okay, so this is the binomial expansion. But we don't care all the terms, we just care the y to 8th power. Here, 2y to 10th power, you will get y 10th power. 2y to 9th power, you will get y 9th power. Only this term will give you y to 8th power. Y to 8. Others will not give you y to 8. So you are focusing on this term. You will focus on this term. What this is? Let's compute. 10 choose 2 is 10 factorial, 2 factorial. 10 minus 2 is 8, 8 factorial. Here, 2 to 8 and y to 8. 3 squared is 9. Okay? Let's compute 1, 2, 8, 9, 10. 2 factorial is 2. 8 factorial, 1, 2, up to 8. 2 to 8th power, what is 2 to 8th power? It's a 16 squares, 256 times y to 8th power and times 9. And 1 times up to 8, 1 times up to 8, they cancelled. 2 cancelled with 10, you get 5. 5 times 9 is 45, so you get 45 times 256 times 9 times y to 8. So you just do the bare and do the computation in your bare hand. You will get this is 103,680 times y to 8th power. So the coefficient, so you can answer the coefficient is 103,680. Well, that's it. So only the final computation take time. Only the final computation take time. Okay. Okay. This is the example. Next, let's prove the observation we just found. Remember that we found that whenever you add two adjacent term, you will predict a term in the next level. So what is the meaning? So they are, for example, this 4, 6. 4, 6, they are in the same level. So 4, 6, they're in the same level. Assume this level, this position 6 is is a 4 choose 2, so it's true n choose j. Then 4 is n choose j minus 1. N choose j minus 1. And it is equal to 10. What is the 10? 10 is in the next level, n plus 1. The level n plus 1, next level. 10 is also the third position. It's like the same position as 6. 6 has position j. So that's it. So this is the formula in the textbook on page, it's a theorem, on page 974. 974. And this one, you can just imagine that this is a 4 choose 2 plus 4 choose 3 is equal to 5 choose 3. So you get these two identical and these two identical. The proof, I'm not going to give you the details of a proof. The proof is in the textbook. It's just a plain computation of the factorial because we didn't have the section of factorial computation. So I'm going to skip the proof. You will not see the proof of such formula in the exam. Don't worry about it. But you have to know we actually have something like this. If you're interested, you can do the computation by yourself. Check it. But in this section, to really expand some binomials power or find a specific term of the binomials is required. Okay, so this example and this example, they are required. Maybe you are asked to totally expand some powers or just find the coefficient of the specific terms. Okay? So let's see one more example and we will finish. Find the sixth term in the expansion of what? Of x plus 2 to 9th power. Okay, so first you have to really expand it. So x to 9, x8 times 2, x7 times 2 squared, x6 times 2 cubed, x5 times 2, 4. We need 6, so the first, second, 1, 2, 3, 4, 5, and next one, 6. Okay, and we only need the 6th term. We don't need other terms. So let's check what this is. What is the coefficient? The coefficient will be 9, choose 5. Okay, 9 comes from here. 5 comes from here. Even though this is a so-called 6th term, it's 9, choose 5. There's no 6. This is actually 6 minus 1. Okay, so how do you determine the coefficient? 9 comes from the total power. The bottom j comes from the power of a. Okay, so the 6th term is 9 choose 5 x to 4th power 2 to 5. 2 to 5, what is 2 to 5? 35. 32. Check it, 2 to 5 is 32. Okay, and then 9 choose 5 is 9 factorial over 5 factorial over times 4 factorial. 9 minus 5 is 4 factorial. And have 32 x to 4th power. And then you do the computation. This is 1 times 5, 6, 7, 8, 9. 5 factorial. 5, 1, 2, 3, 4, 32 x to 4th power. Okay, 1 to 5, 1 to 5 cancelled. 2 times 3 is 6, 6 with 6 cancelled. 4 cancel with 8, you get the number 2. So what do you have? You have 7 times 2 times 9 times 32 and times x to 4th power. And you really do the computation. This is a product. It's not that difficult. The product is 4032 and times x to 4th power. And this, including x, is the term. This, including the x, is the term. Okay? So it's always, the term always contains the coefficient, contains the x. The example, previous example, we only ask for the coefficient, so it is a number. Okay, you don't include y to 8. Okay, cool. So this is the section 13.5. Do the exercise, recommended exercise, and if you have a question, send me a message. Thank you.